Welcome everybody. Friendly neighborhood calculus teacher back with a bonus topic 9 video. This is a BC only topic. It's on polar. Wanted to look and share a brief few comments about the multiple choice questions. So 26 is a non-calculator question. Hope you've read it. If you haven't read it or done it, we need the slope. So in order to find the slope, and this is where polar parametrics and vectors make sense together, we need dy dx. To get dy dx in the polar sense, I need dy d theta and I need dr d theta. To get dy d theta, I need to remember that y converts polar coordinates using the formula r, whatever that is for the different function, times the sine of theta. X uses r times the cosine of theta, whatever the formula is. So my hints, use x equals r cosine of theta, y equals r sine of theta. We end up getting letter B. So you could use the product rule. Well, you're going to use the product rule, but I'm saying you could distribute, or you could just use the product rule straight up, whatever. This is tedious because it's non-calculator, but not actually, or shouldn't actually prove to be super difficult if you're familiar with these things. 91 is a calculator active question. We have 2 cosine of 3 theta and r equals 2. R equals 2 is the circle. And what we're looking for is the area that is inside the circle, but outside of the polar curve, 2 cosine of 3 theta. That's one way to think about it. Another way you could think about it is we want the circle, but for the 2 cosine of 3 theta. And there's many ways to actually complete this integral. The total area of the circle is the area of a circle 2, so 4 pi. You could also do that with the polar area, which is 1/2 r squared, which is 2 squared, d theta. You just have to figure out what the limits of integration are. If it's from 0 to 2 pi or 0 to pi or whatever, just got to be careful. Or you could just say it's 4 pi, that's fine. The 2 cosine of 3 theta is a little bit more difficult to do. So my suggestion, as always, if possible, is you want to study the graphs on the graphing calculator. So if you do that here, you can look at this polar graph and you can figure out where like one petal starts and ends, and then triple that. So you would do 1/2 times the integral of 2 cosine of 3 theta. Remember to square the whole thing. You need to square the 2 also. So quantity, it's not really quantity, but hopefully you know what I mean. D theta multiplied by 1/2, and then multiply that result by 3. So long as your limits of integration correspond to a full petal, that's going to work. Another thing you could do is do a 1/2 petal and multiply by 6. So you have lots of options here when it comes to the polar areas. Just doesn't feel like it because it's so hard to wrap your brain around. All right. 26. Which of the following represents the total area enclosed by the polar curves? This is a tough one to graph, which is why I'm trying to remember here. Yeah, I'm pretty sure this is non-calculator. So I recommend for multiple choice, if you're really not sure where to go, start looking at the answers. So from looking at the answers, you might be tempted to immediately say B and D are out. Okay. So why would it make sense to say B and D are out? Because they don't have a 1/2. But here's kind of the sneaky thing you need to remember is if you're doubling something, the 1/2s would cancel out. So unfortunately, that's not necessarily going to be enough for you to make hay. So how do you do this? Well, all of these, fortunately, are from 0 to pi. So what we can do is we can think about what's going on at values between 0 and pi to try to make sense of what's going on here. Okay, so like say pi over 2. So the sine of pi over 2 is 1. If you square 1, you get 1. So we know we're right at the top of this thing right here. Okay. So then I might try something between 0 and pi over 2 to see like which side of the curve I'm at, because it could do all kinds of weird twisty stuff, right? This is a polar. Who knows what they're doing? They're tricky. So if I do pi over 4, sine of pi over 4 is root 2 over 2. If I square root 2, I get 2. If I square 2, I get 4. So I get 1/2. So it looks like I'm in the first quadrant. So it probably starts at the origin, goes up through the first quadrant, and tops out. Okay, when we're at pi, we're at back to 0. Okay. So I know 0 to pi represents, like I'm pretty convinced that 0 to pi represents just one of the loops. One of the loops. That's why D makes sense here. Because even though there's no 1/2, I've squared sine squared to get sine to the 4th power. But I'm doubling the area from 0 to pi. Thanks so much for your attention on another AP Calculus exam review video. This is me, friendly neighborhood calculus teacher, saying peace.